Good morning students. Up to now we have studied about the electrical motor. Okay, in that we have studied that force is of act on an electric conductor when we placed it in magnetic field and electric current is passed through it. Okay, if it is perpendicular to the direction of magnetic field, at that time large forces act on electric conductor, and if it is in parallel of magnetic field, at that time force will not act on that electric conductor. Okay, for that we also see the left hand rule, Fleming's left hand rule, to find out the direction of force acting on electric conductor. Okay, so such a way that next topic we have to see, that is the electromagnetic induction. Electromagnetic induction. I already told you electricity and magnetism are nothing but the two parts of a coin. Okay, we can produce magnetic field by using electricity. Okay, that we already studied. If we see any current carrying conductor, then around that current carrying conductor one field is generated, and that field is nothing but the magnetic field. Okay, what field is generated around current carrying conductor, and that field is what? Magnetic field. Okay, also electromagnetic induction. Okay, then around the magnet also there is presence of magnetic field. Okay, so here electromagnetic induction, it is the concept which tells us that we can generate electricity by using magnetism. Okay, actually for the production of electricity we can directly generate electricity by using only magnetism actually. Okay, so there are, by using magnetic field we can generate electricity, or we can flow charges present in an electric conductor, that is the nothing but the electromagnetic induction. So we can say that we can introduce electricity in an electric conductor by using magnetic field. That phenomena is simply called as the electromagnetic induction. Okay, induction of electricity in an electric conductor by using magnetic field is simply called as a electric conductor. Okay, so the one electrical device we have to study here, that is the galvanometer. We have heard about galvanometer. Generally galvanometer is very sensitive to the electric current. Okay, if very small electric current is passed through electric circuit, okay, very small, in range of millivolt, microvolt also. Okay, so milliampere and microampere voltage, it is the voltage measurement, voltmeter. But now here in case of electricity, a very small electricity in range of milliampere or microampere is passed through that device, then it can be sense that electricity. Okay, so it is a very sensitive to the electricity. So if you see the structure of galvanometer, then we will see that this is a one knob of a galvanometer, and here are we see some readings on the two sides of the galvanometer. This is 0, and such a way that readings are present on the both sides of galvanometer. Okay, so both sides means if current flowing through in this direction, then we can see reading in this direction. If direction of current is reverse, then direction of deflection will also be changed in this galvanometer. Okay, so such a way that galvanometer is a very sensitive to the electric current. Okay, now the working of this galvanometer is also same as like a electric motor. Okay, in the electric motor we place one electric conducting coil placed between two poles of magnet. Here is also what happened, one coil is placed. Suppose these are the magnet, one coil is placed here inside the magnet. Okay, here a magnet is present and one coil is here, and here on one sheet of a metal this knob is present here and this marking is present over here such a way that, okay, so what actually happen here, here we see some marking, this is 0, this structure actually present over here. Okay, so what happens, as the electric current pass through this conductor, okay, this coil is means or simply electrical conductor. As electrical conductor, electricity is passed through it, what happen, force will act on this knob. Okay, because as we place electric conductor in magnetic field and as current pass through it, what happen, force will be act on this knob, that is the electrical conductor, and deflection in that knob is takes place. Okay, same case we have studied in case of electric motor, that there are two poles of magnet are there, and that diagram I actually draw here. Okay, such a diagram you are already studying. This diagram is studied there. Okay, this is the path of electric current, this is another one magnet. Suppose this is north, this is south pole, we name here A, B, C, D such a way that, okay, are you see that concept electric motor, same cases happen here. Okay, we place this foil on this electric conductor and we connect this knob to this foil, so current pass through it and it placed in magnetic field. At that time deflection or force on that knob is act, and as what the direction change, direction of current change, knob will flow according to, or knob will be change their direction according to current. As the direction of current change, direction of knob also takes. Suppose it will be go here, and if direction of current change, then it will be go here. Okay, so such a way that we can measure the amount of current flowing through an electric circuit. Okay, so such a way that this working of galvanometer is takes place. Okay, so galvanometer is what, simply it is an electrical device which is used to measure electric current, or it is very highly sensitive to the electric current. We can predict whether electric current is flowing through circuit or not by using this galvanometer. Okay, the working of galvanometer is on the basis or same as like working of electrical motor. So electrical motor is working on the concept of, if we place electric conductor in magnetic field and we pass electricity through it, then force will act on that conductor. Same here, we place this electrical conductor in the magnetic field. So as what happen, as current pass through it, force will be act on this conductor and it will move from their position. So it will show us reading. So as we change the amount of current, then also deflection will be changed. Okay, so as we change the amount of current, if you decrease the value of current, then we will show less reading because less force will be act on that. If you increase the current, then large force will be act on that, so it will be show us maximum reading. Okay, so such a way that what happen, this working of galvanometer is takes place. We have to use this galvanometer in the study of electromagnetic induction. That is why we have to study first galvanometer. So only we have to remember here, it is a very highly sensitive to the electric current. If a very small change in electric conductor or if a very small current is passed through an electric circuit, that can be easily sensed. Okay, so that we have to remember. Now we have to see the concept of electromagnetic induction. So now we have to see topic electromagnetic induction. For study of electromagnetic induction, to understand this concept, we have to consider one coil and we connect this coil to the electrical battery. Okay, so we connect this coil to the electrical battery here, and here we consider one another coil here. Okay, one another we can say conductor. Okay, so in book they give it name of that is the coil. It is a coil, wire coil. That is the wire coil is here. Okay, conducting wire coil is here, and one galvanometer is placed in this coil, wire coil. Okay, connect to this wire coil, because if any small change of electric current takes place, then we can easily catch it. Okay, we can understood somewhat electricity is flow here. Okay, so now at initially, suppose this coil is stationary, this setup is stationary, and this coil is also stationary. Now initially we have to consider if electricity is not passed through this coil. Okay, at that time whole scenario remain as it is. Okay, but as we start the flow of electric current, at that time what happen, electric current will flow through these coils, and due to the flow of electric current through these coils, what happen, magnetic field is generated around this coil. Okay, what, due to the flow of electric current, if electricity is a flow through conductor, at that time magnetic field is generated around this conductor, so such a way that flow production of magnetic field is takes place. Okay, so as we initially turn on the button, and if we see here, then we will see that small deflection in this galvanometer is takes place, and again it come on its original position. When at initially when we turn on electric current, at that time some deflection we will see here, and for that small instant it deflects and again come on its original position. Okay, so we can say that automatically as we turn on electric current here, due to that current, this coil here, actually we do not connect any electrical supply, this is only electric coil. Okay, so here due to the passing current in this coil, what happen, electricity generate in this second coil. Actually here electric connection is not be given to this coil. Okay, so what happen here, actually due to the passing of electric current in this coil, automatically electric current pass through this second coil, because we see somewhat deflection in this galvanometer. Okay, and but this coil is stationary, so for a very small instant we see this deflection, and again this knob is come on its original position. So deflection takes place here, it means that electricity is a pass through this coil. Now what we have to do, we have to move this coil. Okay, we have to move this coil. As we start motion of this coil away from this coil, okay, so we will see deflection in this galvanometer. Okay, so what happened, as we start motion of this coil away from this first coil, then we will see current is passing through that coil. But here what happened, we cannot supply any electrical connection. Automatically only the motion of this coil, what happened, electricity is produced here. Okay, same way if we carry this coil towards this coil, again what happened, throughout the motion we will see deflection in this galvanometer. Okay, but actually original condition is what, we cannot supply any electrical connection here. Outside we not provide electricity over here. So that is why what happen, automatically as we move this coil in this magnetic field, okay, in this magnetic field, what happen, deflection we will see in this galvanometer. Now if you carry this coil towards this coil and place at one particular stationary position, okay, now we carry towards this coil and place here. As we place it steady, then we will not show any deflection in this coil, okay, not show deflection in this coil. We can see deflection only when we can move this coil. If this coil is in motion, then and then we can see deflection in this coil. If this coil is stationary, at that time we cannot able to see deflection in this coil, okay. So such a way that actually in throughout the motion, what happen, we here we not connect any electrical supply, but still we see deflection in galvanometer, means current is flowing through this coil, okay. But actually what happen here, we see around this electrical conductor magnetic field is produced, and as we go away from the conductor, then strength of magnetic field decreases, okay, means change in magnetic field is takes place at every point when we go away from this coil, okay. So magnetic field changes, and if we place electric conductor in the changing or varying magnetic